Good morning, everyone. Welcome to the breakout session on Amazon CodeGuru. I am Srinivasan. I am a senior ML manager with Amazon Web Services, and Daniela will be co-presenting this session. Yesterday, we heard about the exciting ML service called Amazon CodeGuru. Amazon CodeGuru helps developers improve code quality, improve application performance, and reduce fleet costs. So today we'll be going deep into details of Amazon CodeGuru. We'll show you how you can onboard Amazon CodeGuru. I'll show you the kind of recommendation Amazon CodeGuru provides so that it can help you with your journey in code quality and performance optimization. So let's start with Lynn. Lynn is supposed to represent several of us in this room. Lynn is a tech lead working on Java projects. She is responsible for several critical projects in her company like search, ordering, and shipping. And she's part of a distributed development team. So let's look at a couple of interactions Lynn has with her team members. So in the first interaction, a developer comes to Lynn and says, we found a data corruption issue in production. And Lynn says, okay, let's go ahead and find out what's going on here. And after 4 hours, the developer comes back and says, look, we have a concurrency issue, and that's the root cause of data corruption. And Lynn says, okay, let's go ahead and fix it. And at the same time, she thinks to herself, look, could we have found this issue earlier during our code reviews, and why is it showing up so late and having all this impact? And the other one, she also wishes that there is experts on concurrency in a team who can actually help the developers address these issues more proactively than reactively. So this is one of the incidents, and let's look at the other one. The on-call comes running and says, look, we have latency increase in production, and Lynn says, okay, go ahead and find out what's going on. And after an hour, the on-call comes back and says, our CPUs are overloaded, and we need to increase our fleet sizes to bring the latency down. And Lynn thinks for a moment and says, look, we just increased our fleet sizes a month back, and we have not seen any big increase in traffic, so what's really going on? And the developer doesn't really have an answer at that point in time. And again, Lynn says, okay, let's increase the fleet size and make sure our customer experience is not impacted. At the same time, she thinks to herself, how do we know what's actually going on here, because we are running into these problems, and we are coming up with some quick solutions at the same time. Do we know the root cause? And she again thinks, she wishes that there is a performance expert in her team to help with these kind of issues. So as I mentioned, Lynn represents several of us in this room, and you can recollect similar or very similar incidents in your daily lives. And what she's really thinking is, how can we improve the code quality? And the second one is, are we giving the lowest latency to our customers? And or our infrastructure cost just bloating? Do we really know, are we getting the ROI for our infrastructure? And finally, the most important one is, what's it out there which we haven't discovered yet? That's a little bit concerning. So I'm sure, a lot of us can relate to, not exactly the same incidents, very similar incidents. We have thought very similar thoughts and so on. Right. So before going into how we can address or help Lynn with some of these issues, let's look at the ecosystem, the environment Lynn is operating in, because the goal of this, Lynn is not a separate person having separate set of concerns. Lynn represents most of us here. And Lynn follows the standard software development lifecycle all of us are familiar with. We are following, you first write code and do code reviews, then you build and test your code, you deploy the code in production, and you monitor and measure what's going on in production, and based on what you see, you go back and improve, and it goes back to the code, and the cycle repeats itself. And again, there's nothing new here. right? And there are several tools, I mentioned code review, then there are these CI/CD tools, there are operational metrics such as latency, there are dashboards, there are alerts. So this is the ecosystem we live in, and I'm sure all of us are familiar with this. All right. So now let's go back and see what's missing in this ecosystem. Right. The first one is we want to detect issues early on, then go find them out later in the cycle. So that's absolutely important. And the second one is software development. There are so many aspects in software development, and it's impossible for developers and teams, especially small teams, to keep up with everything that's happening and be up to date. So that's the second one, and the third one is identifying performance bottlenecks and linking them to code. So if you look at the incident we saw earlier, developers know, or the on-call knows that the latency is increasing. At the same time, it's not clear what's really going on, and because the software is complex, there are several thousand methods, and what should we do to fix or address these issues? And the other one is large learning applications are typically black boxes. You really do not know what's going on. Going back to the same thousands of methods, you don't know which methods are running, how often they're running, and things like that. So you want a little more clarity, a little more visualization of what's going on in your large deployments. And the other one is availability of expertise. So all of us know that talent is scarce, and expertise is even scarcer. So and this applies especially to small teams. So how do we have the expertise needed to run and be responsive to incidents? And the other one is faster time to resolution. If you look at the incident, people took several hours to identify the root cause, and even after that, it's not clear what's really going on. So this is another of the issues. So what we really need is an integrated tool which gives you a perspective across the life cycle, not just siloed perspective of what's going on in a given phase or a given stage. And the other important requirement is the tool should provide actionable recommendations across the phases, not just vaguely point out a problem that, okay, give an alert. I think we get a lot of alerts. So it shouldn't stop with just alerting. At the same time, it should give actionable recommendations. So the most important thing to realize in this situation and discussion we have had is that it's not that Lynn doesn't trust her team. She definitely thinks the team is competent. They are doing their best. At the same time, she's looking for additional help. I think that's the way to look at it, rather than, people are definitely, things are so complex that teams can get additional help with, tools. And guess what? That's why we created Amazon CodeGuru to help people like Lynn operate faster and detect and remediate issues faster. And Amazon CodeGuru addresses several of the problems we talked about, and that's the reason we built Amazon CodeGuru. Now that we have seen that, what I'm going to now talk about is give a quick overview of what Amazon CodeGuru is, how it fits into the lifecycle we saw earlier, and then I will go deep into the Amazon Code Reviewer, which provides code review recommendations, and then Daniela will talk about the Amazon CodeGuru Profiler, which helps you analyze and improve your runtime performance. And during this, both of us will be giving demos on how you can onboard and the type of recommendations and how you can get what you can get out of Amazon CodeGuru. Okay, so that's the agenda for the rest of the talk. So let's dive deep into what Amazon CodeGuru is. So Amazon CodeGuru is essentially an ML service for automated code review and application performance profiling. And it touches upon, I'll show you, what are the different aspects it touches upon. And the second one is it's based on decades of knowledge and experience at Amazon. So it captures several of the best practices, and it's trained on Amazon code base and open source code base. And the other important thing is when developers use Amazon CodeGuru, they see the recommendations and they can provide feedback on the recommendations. And CodeGuru evolves and improves with these recommendations, though these recommendations are absolutely essential for not, the thing is they definitely improve the performance of Amazon CodeGuru. And Amazon CodeGuru searches for optimizations continuously, even in production. It has a low overhead, so you don't need to be worried if I'm using this, it's going to slow anything down. So you can use it continuously in production. And it provides actionable recommendations on how to fix issues. So you're not left guessing. So there is something specific, and you can agree or disagree with it and give feedback. So that's ties it back to the feedback, right? And Amazon CodeGuru automatically inspects code for hard to find defects, and that's the CodeGuru reviewer, and it helps you find the most promising methods in your application for optimization. So going back to what I said earlier, so your application may have thousands of methods, and it's not clear what is the most promising one you should start with or without a problem. Okay, you don't need to wait for a problem to optimize your application. So it helps you prioritize where you should focus your resources on. In short, basically it's like having a distinguished engineer on call 24/7. So this goes back to the expertise aspect I talked about. Lynn wishes that she has someone who is expert in concurrency, who is expert in performance with her team, and CodeGuru helps you with such goals. So now that we have seen Amazon CodeGuru, let's see where it fits in. So this is the development lifecycle several of us are using, and Amazon CodeGuru Reviewer fits early on in the cycle. It provides code reviews with actionable recommendations, so you can use it as part of your code review workflow. And the CodeGuru profiler you can use to detect and optimize expensive lines of code pre-prod, so that these performance issues don't go into production. So it helps you with both with the coding phase as well as the build and test phase before deployment. And guess what? You can actually use Amazon CodeGuru profiler in production. As I mentioned, it has very low overheads, and you can easily identify performance and cost improvements in production. And you can analyze what's going on if you have incidents or examples we saw earlier. So it touches upon multiple aspects of the development lifecycle we have seen. Okay, so that's about Amazon CodeGuru as a whole, and now I'm going to go deep into Amazon CodeGuru Reviewer, and let's see what the CodeGuru Reviewer does. First, it provides automated code review recommendations which are actionable, and the second one is it supports Java applications. So if your packages contain Java, you can get comments from CodeGuru Reviewer, and it is integrated with GitHub and AWS code commit repos. So if you're on any of them, you can get started right away. And it leverages pull request based code review workflow. Pull request based code reviews are very popular, and so it seamlessly plugs into your existing workflow. So there is not much to learn. So I'll give a very brief overview of what a pull request based code review is for people who are not familiar. So let's assume Lynn or her team members, they are working on a new feature or a bug fix. So typically what they do is they create a branch, and they do all the changes in the branch. And after testing, when they are satisfied with what they have created, they create what's called a pull request. So it notifies the reviewers to pull the code and examine it. And the code reviewers provide code review comments, and there is a interaction that goes between the code author and the code reviewer. And after all the changes are approved, the code is merged back into the main line. So that's the pull request based workflow. So now let's see what Amazon CodeGuru reviewer does and how it fits into the workflow. Okay, so I'll talk about some of the key challenges in this before going into the, how it fits in. The challenges with code review, one is expertise. So we talked about availability, we talked about compliance and correctness aspects, and several times these aspects do not get addressed in code reviews because of lack of expertise. And the second aspect is code reviews often demand senior developers, and these developers may not have time, or if they spend time on code reviews, they may not be available for other critical tasks. So there's a trade-off that's going on here. And the third one is a typical software touches upon multiple functional areas. Some of the examples are the use of AWS APIs, the use of concurrency, and we talked about compliance and so on. So there are so many areas that teams may not be up to date with with all of the areas, and the code quality is not really what you want. And the other important aspect people may or may not know is human code reviews often focus on business logic and less on functional correctness. And again, a lot of it is mainly because of availability of time. It's not that people do not know about it. At the same time, given a limited time, people will rather focus on the business logic than the functional correctness. And finally, the size of the code, the number of repos, they are always increasing, and to look at a code and provide code review comments, it just takes more and more time. Right. So, these are some of the challenges with the code reviews, and now I'll tell you how Amazon CodeGuru reviewers addresses some of these problems. The first one, it goes back to what I said. It focuses more on functional correctness and flags critical defects and reliability issues. And so that's what you get out of this, and it leverages the familiar pull request based code review process. This is what we saw Lynn was using, and it plugs seamlessly into this process. So CodeGuru reviewer is just another reviewer part of the code review, and provides comments exactly the same way. You can react in very similar ways, and so that's the thing about code review. And it's very important to note that CodeGuru reviewer is not meant to replace human reviews. It's CodeGuru reviewer basically augments the human reviews and addresses some of these areas which people may not have time to address. So now that I talked about finding defects, let me talk about the code areas that are addressed by Amazon CodeGuru. The first one is the correct use of AWS APIs. So if you look at AWS, AWS has hundreds of services, and the APIs have certain nuances which developers may not always be familiar with, and not knowing them can actually impact both the performance or the correctness of your code. For example, if you are doing polling instead of waiting, then you suffer performance, and I'll talk about pagination. If you don't use pagination, you may end up with incomplete results, which affects the correctness of your code. And the other one is concurrency. Concurrency is hard even for expert developers. They may need to look second or third look at the concurrent code, and this is where they can use help. And concurrency again can lead to both correctness and performance issues. Like if you are missing a synchronization construct, you may be reading the wrong data, or you may be corrupting the data, or if you do something like over synchronization, then your performance suffers, and this impacts availability. And the other one is resource leaks. So resources are anything like database connections, HTTP connections, files, and there are so many types of resources. And resource leaks are often not caught by unit tests. Even concurrency issues are not caught by unit tests. So, and incorrect handling of resources can result in slowdown, and it impacts availability. And the other one is sensitive information leak. Handling sensitive data is again a specialized topic, and it is just evolving, and teams may not have expertise in that area. So leakage of sensitive information like leakage of credit cards can actually lead to compliance issues. And the last category is a catch-all category. It is there are multiple type of defects which are identified by looking at large corpuses of code, and these cover multiple functional areas. For example, one of them relating to not creating a client for each Lambda invocation that relates to AWS best practices. So there are multiple categories in this area, in this bucket, and addressing these issues improves the code quality. So now that we have seen how it fits in, what are the functional areas it addresses, let's see how you can start using CodeGuru. So you have your code repo, and the first step you want to do is you want to introduce CodeGuru to your repo, and that is a one-time operation that's called the repo association. So once the repo is associated with CodeGuru, then what happens is any pull request created on that repo by any developer reaches CodeGuru reviewer through the code repository. And then once CodeGuru reviewer gets notified, it clones the repo, and it analyzes the code and provides recommendations, and the developers can look at the recommendations and provide feedback, either useful or not useful, back to CodeGuru. And as I mentioned, this feedback is helpful for improving the performance. And here is a very quick view of how CodeGuru reviewer works. Once a developer creates a pull request, the code is cloned, and it is analyzed, and CodeGuru reviewer extracts semantic features and patterns which capture the interactions between program elements, and this representation is then fed. This representation is then fed to ML models, which, as I mentioned, are trained on several 100,000 repos from Amazon and 10,000 repos from GitHub, and the output of the model reach the developer as a recommendation. So in this case, this piece of code has a resource leak. Cool. So now let me go and give a demo of CodeGuru, how you can onboard. So let me switch and show you the CodeGuru console. I guess everybody can see this. Increase the font size a bit. So this is the Amazon CodeGuru console, and it has the reviewer part and the profiler part. As I mentioned, if you want to get started with the CodeGuru reviewer, you need to associate your repository with CodeGuru reviewer. So let's go to associate repository, and we support GitHub and AWS code commit. First, you need to connect to GitHub and then associate a repository. Let me connect to GitHub. And so you had to provide your GitHub credentials. In this case, I had provided it earlier, so it got connected. And now you can get a view of the repos on GitHub. Let me associate this repository. And you get a status of the association. It says it is associating. It takes few seconds. While waiting for the repo to get associated, let me go to GitHub. So this is the repository, and this is the file I am looking at. And so this is about handling shipping events, shipment events, and the shipment events have a status and a timestamp. The status is whether it's in transit, whether it got delivered, and so on. And what this is doing is it's basically all these, the information is stored as S3 objects. So what this does is it consolidates that information and creates a single view of the statuses every 15 minutes. Okay. So this uses AWS S3, and it also uses concurrency for multi-threading. So let me go back and see if the report got associated. Yeah, now you can see that this repository is associated. So now what I can do is I can go here and I can create a pull request. Yeah. And once their pull request is, I need to choose my repo. Okay. Oh, I should. Sorry. Okay. Oh, no, I think I'm using the wrong repo. What is this? Okay, I think let me just go back and create a new branch. And so yeah, with Dev10 I can create a new pull request. Yeah. Yeah. So once I create a pull request, what happens is the information, the CodeGuru gets notified, and it typically takes a few minutes for the code reviews to arrive. So what I'm going to show now is some of the comments CodeGuru reviewer provided on an earlier version of this repository. So as I mentioned, this code uses S3 objects. Let me increase the font size. And the first recommendation by the CodeGuru reviewer is that you're using the does object exist, and you seem to be using it in a busy wait state to check the status of the object, and you can actually use the API's object exists or object not exist along with waiters. That will improve the performance of your code, and you can get additional information about this from here. So this is the first recommendation. Let's go down and see if there are additional recommendations. Okay, there's a second recommendation here which talks about list objects, and what this program does is it calls list objects and takes the first set of results and returns it, and start using it, and it's a less known fact that it can actually result pages after pages, and you should actually look if there are additional pages before start processing the results. So what it says is it's not paginated, and you should use paginated APIs. And there's another problem with this, which basically is you're using an outdated API, and you can use a more recent the list objects v2. And the other recommendation is on concurrency. What it says is you're using a concurrent hash map, and you're using get and put statements in lines 110 and 137. Let's see what's in 110. So in 110, what happens is you're using get on the latest status for tracking number, and in 137 you're using a put. And typically what happens is between the get and put, there can be another thread which does another access to this, and it can overwrite what you have seen. So this can lead to stale information or incorrect information. So what this says is you should actually use put if absent, and with additional logic you will get the performance you want. So that's a summary of what it found on this code, and they just one more recommendation. I will skip it in the interest of time. So let me go back to the presentation. Okay, so this is the demo of CodeGuru reviewer we saw, and there are a few examples which are very similar to what we saw earlier. I'll skip them. So now let's look, we have actually used CodeGuru inside Amazon, and there were thousands of developers using this, and CodeGuru reviewer provided hundreds of recommendations, and the demo as well as the scenario we captured, they are based on the scenarios we got in Amazon. The first feedback says that Amazon CodeGuru reviewers allowed us to catch a long-standing race condition lurking in a critical piece of code. So this goes back to the first incident Lynn had with one of our developers. Concurrency issues are hard to find, and CodeGuru reviewer was able to find a long-standing concurrency issue in code. And the other one says that we weren't using DynamoDB appropriately, and actually this got missed in a code review, and the CodeGuru reviewer was able to flag it, and it's a great catch and a great recommendation. And the final one is it relates to resource leak, and the developer says CodeGuru reviewer recommended try with resources to prevent resource leak, and the developer implemented it immediately. So this is a small sample of the feedback we got from Amazon developers. So now Daniela will talk about CodeGuru Profiler.
Great. Thank you very much. Good morning, everyone. Is everybody awake? Yes. Everybody got their coffee? Excellent. Okay, so you saw how CodeGuru Reviewer can help Lynn improve the quality of Lynn's code. And now I would like to go over CodeGuru Profiler so that you can see how it can help Lynn improve the performance of her applications. But before we do that, I would like to explore what are the challenges that are posed by poor application performance. Why do we have to care about it? So for many companies, inadequate performance has a very negative impact on the business. For example, when you are working with, as a customer, with an online service that is too slow, this creates a poor end user experience. And when this happens, and too much or above a certain limit, that may become unacceptable. So this may lead to, when this happens, it may lead to customers, companies losing customers. And online businesses know from experience that when the latency increases, sometimes it can lead to loss in sales. An application may be underperforming also in a way that it uses the underlying resources, such as compute resources, especially when you have an application that is running on large fleets. Any small change in the average CPU utilization can lead to a big impact on the bottom line. And finally, performance issues have big impact on mission-critical systems or low-latency systems, where even 10 milliseconds delay can lead to sometimes even system failure or serious impact on business operations. For example, if you have railway or aircraft operation system, control systems, if there are performance issues, this can lead to a loss in life. If you have a delay in financial trading systems, this can sometimes lead to millions of dollars in losses. So if we explore what are the underlying causes for all these scenarios, we can notice a couple of repeating patterns. Modern applications are built as distributed services that are running on leveraging cloud compute platforms to increase reliability and scalability. And this is great, but it does pose challenges for developers to identify what code causes problems, performance problems, and get to the bottom of it to fix it. Existing tools do provide information. They provide a lot of raw data and visualizations that are sometimes hard to use. And they do not provide insights into how to fix the problem. And this oftentimes leaves developers guessing what to do. So this leads us to the second problem, which is that performance engineering is a domain expertise that not too many developers have, or at least not to the needed degree. Furthermore, there has been a big increase in the number of software applications written. Millions of lines of code get generated every year. There's been a steady increase in the number of software engineers. However, that of performance engineers hasn't kept up with this growth. So this leaves a sizable gap of a much needed expertise. And this leads to a situation where Lynn has inadequate performance of her applications and not enough people on her team to tackle that. So what Lynn needs to do is rethink how she solves the problems posed by poor application performance. So what Lynn needs to do is to find somebody, preferably on call or something, who has performance engineering domain expertise so that they can quickly tackle a performance problem, somebody who continuously learns and stays on top of performance best practices, someone who continuously analyzes the application so that they can monitor and find out if there are any performance issues, somebody or something who points directly to the performance problem and provides actionable recommendations, and even helps the business to understand what should I be working on, what is the issue that has the biggest impact on the business. CodeGuru Profiler combines the whole array of these skills in a single service that enables Lynn to stay on top of her performance so that she can focus on other very important things, such as creating new software functionality. Profiler is a fully managed service as part of CodeGuru, and it finds the most expensive lines of your code. And the way it does that is because we have trained Profiler to find methods with high potential for performance optimization. These are methods that are unnecessarily increasing latency or reducing throughput and unnecessarily increasing CPU utilization. Not only does Profiler find the most expensive lines of code, but it also recommends you how to fix them. It is an intelligent profiler which has been trained via many years of experience with performance engineering and hard-learned lessons at Amazon. Unlike many other profilers, CodeGuru Profiler is built to run on production without impacting your performance. So it has low overhead, around 1%, and you will barely notice it running. It continuously runs on production and continuously analyzes the performance of your application. It's always there when you need it. When you're reacting to or when you're troubleshooting an application performance issue, or when you're proactively working to improve the CPU utilization and latency of an application, it is always there. Think of it as insurance policy, there when you need it. Currently, CodeGuru Profiler supports applications written in Java. Onboarding is very straightforward. It has 4 steps. The UI leads you through all the steps, so I'm going to very quickly breeze through them. First, you create a profiling group. What a profiling group is just a name that we give to the application that you're profiling. You can have one or more services in the same group, especially if you have microservices, that's helpful. The second step is to update the IAM role used by the profiler agent. We give you the statement for that, just copy it. The third step is to configure the build to include the profiler agent. Again, we show you the configuration, just copy it. And finally, you need to add a couple of lines of code in one place in your application to start the profiling thread. So now I would like to show you how the profiler looks like live. Okay, so let's go to the CodeGuru console and dive into the profiler dashboards. Okay, so what you see here are the profiling groups, and I'm going to go into the image processing app. So the image processing app, as the name suggests, helps you process images. So what you see here is a representation of everything that your application is doing as it runs on the CPU. This is runtime data. And the way that a profiler knows this is because it continuously captures stack traces from your live application, and it shows them in a visualization called flame graph. So what a flame graph is, it's the aggregate, all the stack traces aggregated for a given period of time. You can see all the methods that are running and what percentage they take from the active CPU time. So if you hover over an aggregated method that is part of a given substack, this is going to be over the bar that you see here, also known as a frame. You can see information such as the class name and method name, what percentage it takes from the CPU, and the dollar value of what it costs you to run this particular aggregated method as part of this particular substack. So the more or the wider the bar is, the frame is, the more time it takes from the CPU. On the vertical axis, you have the hierarchical relationship between parent and child methods. So on the bottom, you have the parent, and it calls the child, which goes on the top, all the way to the top of the stack that shows you the method that is actively running on the CPU. On the horizontal axis, you have the alphabetical ordering of your substacks. There are two main visualizations, overview and hotspots. So what we're looking at is overview. And what overview is it just gives you the key entry points into your application. It shows you what are the operations that your application is doing. So let's see what we're doing here. If we go to the base of each of those substacks, you can see that we are brightening an image, darkening image, and so on and so forth. So this is very useful just to see where is my main time, in what operations am I spending my time. So let's look at the hotspots. So the hotspots show you the biggest methods contributing to the CPU utilization. So these are usually lower level methods, and they are aggregated at the top. So if you hover over this fairly big frame, you can see that 60% of the time we're spending unzipping files, which are the images. So both of the views are very useful depending on what you're doing. So I'm going to go back to overview, and I would like to talk about time. So as you know, there are two types of times when it comes to applications. There's the active CPU time, which is what are you doing actively on the CPU, and then there's the wall clock time, which tells you like the whole time, the total time. So this is the CPU view, and you're going to use it usually in cases where you have a CPU-bound application. And if you are working on improving a latency, you're going to look at the latency view. So what you see here are a lot of colors, and all of them have meaning because we show you the thread state. So you have blocked, native, runnable, time waiting, and waiting. What is interesting here is that it shows you what your application is doing, even though it may appear it's not doing anything on the CPU. And that's usually because your application might be I/O bound or network bound, anything that makes your application either be blocked or waiting. So I would like to go to one of the operations here, which is to brighten an image. So as you can see here, we have green stuff. Let's see what's happening with this waiting. So we're looking at the S3 client, which is waiting to upload an image. And it's taking over 2% of the time, of the wall clock time. If we switch to the CPU, then we're going to see that this same method is taking less time, 1.59. And that's because we're waiting on the S3 to upload the image. So both CPU and latency are useful depending on the particular use case that you have. So visualizations are really good in the sense that they give you all the information that you need to know about what your application is doing so that you can look for any surprises. I'm expecting that I should be spending this much time in, I don't know, video transcoding, and instead I'm spending 30% on logging debug information. Why am I doing this? I'm not supposed to be spending all this time. So it is kind of context-driven. You need to know what your application is supposed to be doing, which I hope you do. We also, in addition to the visualizations, we provide automatic recommendations for commonly occurring performance problems. And the way that we know that is because we've trained the profiler models on commonly occurring mistakes that developers make that impact performance. So I'm going to go to the recommendation report, and we have one performance issue here. I'm going to very quickly breeze through it. Each performance issue shows you what the problem is and the impact on the CPU, which is very important. If the impact is big, you want to spend time on it. If it's not, well, maybe leave it for later. Then we show you a description of the problem, why it's happening, suggested steps to resolve the problem, as well as where the problem was found. If you click on any of those links, and I'll show an example of that later, you will see a substack as it appears in the flame graph. So, so this is just an example to show you how the profiler looks like, and now I would like to show you how it can be used for a real application. So the application we're going to look at is very simple. It sells fruits, and there are customers who buy the fruits that the system sells, and there are customers that buy illegal fruits that we don't sell. And we're going to see what these fruits are. So if we look at the flame graph, we can see that there are three main operations, or two. The main one, or one of the main ones, is the listing orders. So basically, as customers are buying, we list those orders. And the other one is creating orders. And those are split in two. One is creating the legal orders for fruits that exist, and the other one is creating the illegal orders for stuff we don't sell. Okay, so let's look at the recommendations and see what is happening. We have two performance issues. And if we start from the top one, we're spending too much time parsing date with simple date formats. And the second problem is we're checking for values not in enum. And both of those take quite a significant chunk of your CPU time. So let's see why this is the case and why you're not spending your time selling fruits. Let's start with the checking values for not in enum. You're spending almost 13% of your time checking for those values. The reason why this is happening is because you're attempting to parse a value not in enum too often. Every time you do that, it results in throwing an exception. And when you do too much of this, it slows down your application. So if we look at the suggested resolution steps, we recommend there are actually three options. One option is just don't do it. Try to see if you can eliminate invalid values. And then if this doesn't work, then consider using Guava's enums.getIfPresent method. Or if you want, because it, by the way, it handles thrown exception better. Or you can also consider using static hash map and use the getOrDefault method on the map. And then we can see where this problem is happening. So I'm going to open the Substack, which will show me that if I hover over enum value of, which is taking 26%, it is throwing the exception all the way up to the fill-in stack trace, which is what's causing the 12.76% of overhead on the CPU. Okay, and let's quickly go to the second problem, which is the slow simple date format date parsing. So the problem, first of all, it's this should be a pretty big signal, like you should do something about it because it's spending almost 30% of your CPU just to parse dates. What is the problem? So the problem is that when you're parsing dates and times using simple date format, the underlying implementation looks up formatting data using date format symbols. So when these symbols are not provided to the constructor, they need to be looked up every time on parse, and this makes your overall application running slower. So the suggested resolution, we have provided code which you can use directly, the directions or instructions from the profiler is that when you create simple date format instance, pass in the default symbols instance to the constructor. So let's see how we can use this information in the application, which you may not be able to see. Okay. Do you guys see the code at all? Kind of? All right. Okay, so this application is, as I said, the fruit selling application, and there's a thread that sells or takes orders for legal fruits, and illegal fruits are mango, strawberry, banana, little did you know. So let's look at the problematic code. We have an enum here that's expecting apple, orange, and pineapple, and because some methods or some customers are asking for the strawberry, banana, this code here, this line here, is going to throw an exception because it's calling value of on enum, and the resolution for this is to replace it with guava's enums get if present. The second problem, if you remember, was that we were having slow date parsing from simple date format, and that's because the symbols were not provided to the simple date format constructor. This is where the code is shown. By the way, we have this on GitHub, so you can go and take a look at it or compile it and so on. Yeah, so if we look at the fix for that, we're literally using the recommendation directly from the profiler to, when you create a simple date format instance, to pass in the default symbols instance to the constructor. So that's going to solve our two problems. And if we look at the before and after, so let's look at the after. So we're going to look at the profiles. So if you hover over the profiles, you can see that the value of, which is the enum, is throwing exceptions which are taking 12%. And if you look at this same thing, it's taking less than 1%. That's get product name calling get if present. And similarly, date format.parse is taking 30%, whereas here it's taking a lot less. So it looks pretty straightforward, and I hope that you get to play with the app. Do give us feedback on that. And I would like to continue or finish the presentation with a very short intro to how it works. So as I said, it's very quick, it's very easy to onboard the application, add a couple of lines of code to start the thread. And when you have an application that is running on multiple instances, EC2 instances or containers, each of those instances is going to run the profiling thread as in-process thread. And this thread, what it's going to do, it's going to continuously capture stack traces, and it's going to send them to the backend, which will then aggregate all these stack traces and run the models on them to see if there are any performance issues. And if there are issues, well, you'll see them in the recommendation reports as well as in the visualizations. And very quickly, we have been using Amazon CodeGuru Profiler at Amazon for a number of years. Hundreds of developers use it on thousands of applications to improve the performance application every day. And this is just an example with a couple of our engineers. So Chris is a software development engineer who was working on a performance issue where the performance was caused by thread contention, and the profiler found that problem, recommended a fix to Chris, who then, after implementing it, the result was that a single host could now serve 7 times more traffic than before. And he was also able to, well, he and his team was able to reduce the number of instances by 75% while still handling the same traffic. And Rajesh is another software development engineer who he had just finished writing codes, and he wanted to make sure that it was not causing any performance issues. And he ran it on pre-prods, performance testing, and he found out that from the visualizations that we're using, or he was using, creating cloning values even when that was not necessary. And these wasted cloning was contributing to a high CPU utilization. So after following the recommendation from the profiler, he was able to enable 40% reduction or between 40 and 67% reduction in fleet utilization. So this is just a couple of examples of the wins that profiler has enabled, and we now hope that CodeGuru Profiler can help you improve the performance of your applications. And now I'm going to pass it over to Srinivasan.
Thanks, Daniela. So I'm going to quickly conclude so that we have time for questions. You can get started with CodeGuru at aws.amazon.com/CodeGuru. You'll see the same onboarding view on the console, and you can onboard to the reviewer as well as the profiler. And this is what you get when you do that. You get recommendations on code quality and application performance improvement, and it continuously learns and improves based on the feedback you give. And from a reviewer perspective, it identifies code defects, provides actionable recommendations on code fixes, and it easily integrates with pull request based workflows on GitHub and AWS code commit. And from a profiler perspective, you get actionable recommendations on performance issues, and you get rich visualization which you can use along with your domain knowledge to troubleshoot additional issues. So thank you very much for your time. And please do not forget to provide feedback on this session. So now we'll have a few minutes for questions. Okay. So the thing is, as you heard, the question is about languages, and as you heard today, CodeGuru Reviewer supports Java, and CodeGuru Profiler also supports Java. And I'll just anticipate a question. The other one is, what are the repos? Currently, we support GitHub and AWS code commit, or you think about supporting more repos. So we are definitely getting feedback from our customers about what are the languages and what are the repos, and then we will we have a list of priorities, and we'll get to them one after the other. Cool, yes. So while the thing is, while Amazon CodeGuru Reviewer provides recommendations related to credentials and sensitive information leak, it's not meant to be a security expert at this point in time. So the current areas we have talked about are related to AWS APIs, concurrency, resource leaks, and so on. So again, as I said, we do get a lot of feedback. The goal of this session is to talk to customers and get feedback, and based on the type of requests and the number of requests we get, we will prioritize this. Yeah.
How's the pricing model work? I guess it's all free, right?
Come again?
How's the pricing model work? I guess it's all free.
The pricing model, you can find more information on the website, and the free tier is for the first 3 months. And CodeGuru Reviewer is charged based on the number of lines of code analyzed, and the profiler is based on the sampling hours of the applications. Yes, please.
You said that when the reviewer runs, right, it clones the code. So where is the code stored? Is it released after that?
So the question is about, do you store code, and Amazon CodeGuru reviewer does not persist customer code. We analyze the code and provide the recommendations. After that, the code is deleted. So we do not persist customer code. Yes. So this is again another of the features we have heard from customers. So currently in the pull request based workflow, the review comments are on the chain lines of code. At the same time, there is a ton of code out there, and this is called a package scan, and so this is also one of this item also belongs to our list, and based on how many people we want it, we will prioritize it. Cool.
We can take questions outside.
Thank you very much. Thanks for your time.